Generally, it can come up to 5 marks as per the new pattern of board. So here is the first question of case study from electricity chapter. First, read the whole paragraph. The question will be as it is. Answer the question based on your understanding of the following paragraph and the related studied concepts. And the concept is a continuous conducting path between the terminal of a source of electric energy and electrical components along with the electric current flows is called electric circuit. The circuit are of two types with their definition: open circuit and closed circuit, with two devices also: rheostat and galvanometer. And after all these things, we have to answer 4 questions. Okay, don't get confused. We are having open circuit, closed circuit, rheostat, galvanometer. And after this, 4 questions will be asked. So first question, SI unit of electric charge. Okay, I'm getting the answers from Nandika, Ayush, Akshat. It's Coulomb, not Columbus. Akshat Jain, it's not Columbus. Second, what is the difference between open and closed circuit? What is the difference between open and closed circuit? If anyone want to say, just raise your hand. I will give the option to speak. Yes, Nandika.
Yes, sir. Good afternoon, sir. Sir, the difference between an open and a closed is that in an open circuit, the connection is somewhere loose, as in such a way that current won't flow through it. Hence, the circuit is not complete. And in a closed circuit, the wires are all connected, and there is no loose connection in between them, so as to so the current will flow equally in every part.
Okay.
Hence there will be no breakage.
Okay. Yes, Riyanshi.
Uh, Good afternoon, sir.
Good afternoon.
Sir, the difference is of a switch. I think when the switch is on, it is a closed circuit, and when the switch is off, it is the open circuit.
How it will be determined that switch is open or closed?
Sir, the dot is there in between the two brackets.
Forget about the diagram. Tell me about the real application. How we will consider the open switch and closed switch.
So when we open the switch, the connection, the circuit get closed so that current
When we
can
open
pass
the switch,
from there.
circuit gets
And
closed.
when
How it
we
is done? ये कैसे होता है? When we open the switch, circuit is closed. ये कैसे होता है? Yes, Darshan.
So when the circuit is closed, the bulb will glow or the light will glow. And when the circuit is not closed or no, it is open circuit, the light will not glow.
How we will decide the circuit is closed or open?
If the switch will be on, then the light will glow. That is called closed circuit.
And what is the relation of open circuit and open switch? ओपन स्विच को हम कैसे एक्सप्लेन करेंगे, ओपन सर्किट को हम कैसे एक्सप्लेन करेंगे?
Open circuit means the bulb will not glow.
And how, कैसे? Why
Because of the
bulb is not glowing?
connectivity.
Why the bulb is not glowing?
Because the wires are not connected properly or the button which is not on.
This can be the reason. Yes, Akshat.
Sir, flow of electrons.
किसको दिखेगा?
हाँ?
कैसे दिखेगा फ्लो ऑफ इलेक्ट्रॉन्स?
नो सर, अगर इलेक्ट्रॉन अगर फ्लो होंगे तो मतलब इलेक्ट्रिसिटी आएगी.
कैसे पता
और
चलेगा
bulb
कि इलेक्ट्रॉन फ्लो हो रहा है?
सर मीटर एम मीटर से.
अब एक छोटा सा सर्किट में बल्ब जलाने के लिए मैं एमीटर भी लगाऊंगा.
I don't know, sir.
Anyone else? केस स्टडी मीन्स ईच एंड एवरी पॉइंट. फंसना नहीं है, हमको एक्सपेरिमेंट्स भी करने हैं. Two ends are there, two terminals are there, which have to join at a single point. For example, bulb. Okay, if the two wires containing two terminals are purely joining the bulb, it is closed circuit. Okay, and those two terminals act as a switch. Okay, सिंपल चीज है, दो वायर को जोड़ना है, ठीक ना, जिसमें कोई भी कनेक्शन. अच्छा, लूज कनेक्शन और टाइट कनेक्शन क्या होता है? देयर इज नथिंग लाइक लूज कनेक्शन और टाइट कनेक्शन. कैसे टाइट करेंगे वायर को? इलेक्ट्रिक वायर को हम कैसे टाइट करेंगे? Anyone? Don't use the word loose connection or tight connection. Simple is connection for the closed circuit means the two terminals should join the bulb. Okay. Third part, can a galvanometer be converted into ammeter? Can a galvanometer be converted into ammeter? What is the difference between galvanometer and ammeter? The basic question is this: what is the difference between galvanometer and ammeter? Ammeter shows current, galvanometer also shows current. तो दो डिवाइस बनाने की क्या जरूरत पड़ी? Very good. Akshat has given the correct answer. But one point Akshat is saying that to measure the current, we have to touch the wire. If we get shock, that means current is there. So I don't think itna high risk लेने की जरूरत है, और भी चीजें हैं.
So the major difference we can tell that the galvanometer, which shows only magnitude.
Okay,
No, sorry, the second one,
what is second one?
ammeter.
Okay,
The ammeter.
and galvanometer?
Ammeter only shows the magnitude, and the galvanometer shows both
What both?
the direction and the magnitude.
How we can determine the direction of current?
Direction of current.
Hmm. उससे क्या पता चल जाएगा कि वो ईस्ट से वेस्ट आ रहा था या नॉर्थ से साउथ जा रहा था, उससे क्या फर्क पड़ेगा?
So I don't know.
Anyone else? Very good. Darshan, anyone else? Akshat, Riyanshi, Nandika, Bhavi. Akshat has given the answer. Akshat, you want to share? Akshat,
Yes, sir.
tell me the answer that you have written.
Sir, in galvanometer it show deflection too, but in ammeter it is not show deflection.
Okay, means the current we are getting in our household, in transformer, in the city cannot be proper. Okay, we can say, we are saying in normal words as voltage problem. जब current थोड़ा सा deflect होता है ऊपर नीचे. So, is he right? Is he right that galvanometer shows the deflection and ammeter shows only the value? Yes, Riyanshi?
Sir, I want to say something. As we know, galvanometer measure very small amount of current, so it has to be converted into ammeter to measure the large amount of current.
Very good.
So yes, it's converted.
Very good. But again, the first part of Akshat concept or sentence, that can galvanometer measure the deflected current and ammeter not? क्या ऐसा होता है? Yes, Viram?
Sir, galvanometer only shows the direction,
Okay.
but the magnitude is given by ammeter.
So we can say that galvanometer current show ही नहीं करता, वो सिर्फ direction और deflection show करता है. Is it so? Viram?
Yes, sir.
Means galvanometer doesn't give the magnitude of current.
Yes, sir.
Anyone else? Anyone else? 3 points we have got from Akshat, Riyanshi and Viram. All are correct or one is correct. Who is wrong? Anyone want to tell? This question number 1 whole will be your a type of homework. It will also help you in the examination also. That come with the single exact answer. Okay. That what is the difference between exact difference between open and closed circuit? What is the exact difference between galvanometer and ammeter? Can it be converted to the ammeter, galvanometer can be converted to ammeter or not? Last, I think everyone knows what is Ohm's law. Define Ohm's law. Fourth part. Give me the exact answer of this. Yes, Rianshi.
Sir, in Ohm's law, it is stated that the current is proportional to voltage and inversely proportional to the resistance.
Okay.
Yes.
Viram.
Yes, sir. Sir, Rianshi was partial right. Ohm's law state that current is directly proportional to voltage. But when we will remove the sign of proportionality and apply equal to, we will get R as a constant.
Okay. Moving to next, Mehul. Yes, Mehul.
Sir, according to Ohm's law, current is directly proportional to potential difference between 2 points in which the temperature and the physical condition remains constant.
Okay. So this is the, you can say, what's written in the book or different references we have learned that V is equals to IR. Okay. Or I is directly proportional to V. So can we say that V is directly proportional to I? If I is directly proportional to V, can we say V is directly proportional to I? And from this, my question is, why not we have started with V? कि वोल्टेज बढ़ेगा तो करंट बढ़ेगा, करंट बढ़ेगा तो वोल्टेज बढ़ेगा, ये ओम्स लॉ बोल रहा है. तो क्या उसका उल्टा बोल सकते हैं, वोल्टेज बढ़ेगा तो करंट बढ़ेगा? So Viram want to say something? Yes, Viram.
सर करंट तभी आएगा जब वोल्टेज मतलब जब पोटेंशियल डिफरेंस होगा, तो मतलब तो एक ही है, चाहे A is equal to B बोलो या B is equal to A बोलो.
अच्छा, means I am taking the current, I am writing in the chat box, I am taking I is equals to, sorry, I is equals to 5 and R is equals to 2. So my voltage will be, I think, 10. Okay. Now I am reversing it.
Yes, sir.
I am reversing it. Now I am taking the I as 2 and resistance as 5. Again, my voltage is 10.
Yes, sir.
Means I 2 रहे या 5 रहे. Means 2 is equals to 5. According to this, 2 is equals to 5. ऐसा होना चाहिए.
सर उन दोनों का प्रोडक्ट है वो, अपन एक के उस बिहाफ में उसको वो नहीं कर सकते जज,
तो
वो
तो
दोनों का प्रोडक्ट है.
R तो कांस्टेंट है ना, R तो हमने डायरेक्टली प्रोपोर्शनल किया था, जो प्रोपोर्शनलिटी कांस्टेंट बुक में साफ साफ लिखा हुआ है.
तो सर आप चेंज भी तो किए ना, आप जब रिवर्स किए तो I2 हो गया और R5 हो गया, तो कांस्टेंट कहाँ रहा, वो तो चेंज हो गया.
So you said na A equals to B, so B equals to A. So 2 equals to 5, then 5 equals to 2. If I is
नहीं
equals
सर,
to
मैं
2
उस
and
टाइम
I
से
is equals to 5. Wait, Rianshi wants to say something. Yes, Rianshi.
सर अगर आप बोल रहे हो कि 2 is equal to 5, तो उस टाइम आपको I बस 2 चेंज करना था, R को 2 ही रहने देना था, उसको चेंज, अगर आप दोनों चेंज करें तो
मींस किसको चेंज नहीं करना है?
सर आपको रेजिस्टेंस सेकंड सिचुएशन में चेंज नहीं करना था, मतलब.
Very good. If I am taking the formula V equals to IR, I am having different values of I should maintain the value of R because I am saying that R is proportionality constant. Okay. And second thing is, as per my question, that हमने कहा है कि करंट से वोल्टेज बनता है। जब हम वोल्टेज का या पोटेंशियल उसको जो बोलते हैं उसका डेफिनेशन हम देखें तो उसमें साफ साफ लिखा हुआ है, पोटेंशियल इज द वर्क डन ऑन चार्ज फॉर प्लेसिंग फ्रॉम वन पॉइंट टू अनदर। एक चार्ज के ऊपर जब काम होता है, वर्क डन होता है, तब वो पोटेंशियल बनता है। वो चार्ज जब टाइम के रेस्पेक्ट में फ्लो होता है तो करंट बनाता है। तो पहली चीज कि उस चार्ज से वर्क कराना, दूसरी चीज कि उस चार्ज को टाइम के हिसाब से कंपेयर करना, ये दोनों चीज पोटेंशियल और करंट देता है। जब W अपॉन Q होगा तो V मिलेगा, ठीक ना। जब Q अपॉन T होगा तो I मिलेगा। Q इज इक्वल्स टू IT एक फॉर्मेट होता है, फॉर्मूला। आई थिंक एवरीवन नोस Q इक्वल्स टू IT। यस खुशी?
यस सर। तो सर आप पूछ क्या रहे हो?
आई एम सेइंग, माय क्वेश्चन इज, I इज डायरेक्टली, I करंट बढ़ेगा तो वोल्टेज बढ़ेगा। नाउ द क्वेश्चन इज, क्या वोल्टेज बढ़ेगा तो करंट बढ़ेगा?
यस सर।
अगर रेजिस्टेंस कम हो गया तो?
सर वो रेजिस्टेंस के ऊपर डिपेंडेड है।
वेरी गुड। दैट
अगर रेजिस्टेंस कांस्टेंट है
हाँ।
तो बढ़ेगा, अगर कांस्टेंट नहीं है, वेरिएबल है, तो फिर कंडीशनल है वो।
वेरी गुड। एंड उसी वेरिएबल रेजिस्टेंस को नापने के लिए रियोस्टेट बनाया गया है, जो आपके स्क्रीन पे है। रियोस्टेट इज द वेरिएबल रेजिस्टेंस। ओके, देखो रियोस्टेट का डेफिनेशन पढ़ो। रियोस्टेट इज डिफाइंड एज द वेरिएबल रेजिस्टेंस। अगर रेजिस्टेंस वेरी किया तो रियोस्टेट से उसको कैलकुलेट किया जाएगा। एंड दैट डिपेंड्स, तो जो फ्लक्चुएशन हमने गैल्वेनोमीटर, एमीटर, ये सब में देखा करंट, उसकी वजह से रेजिस्टेंस भी वेरी करेगा। तो ये जो ओम्स लॉ है, हो सकता है कि ओम्स लॉ के ऊपर ही एक पूरा केस स्टडी दे दे। ये तो पूरा सर्किट और उसके अंदर सारी चीजों का दे दिया। सो दिस शुड बी वेरी मच क्लियर कि करंट वोल्टेज बनाता है, ठीक ना। वोल्टेज करंट नहीं बनाता, क्योंकि वोल्टेज के हिसाब से अगर हम देखेंगे ना तो एक आ जा रहा है वैल्यू R, जो उसका काम बिगाड़ दे रहा है। जस्ट लाइक जब हम मैथ्स पढ़ते हैं तो y इज इक्वल्स टू mx प्लस c पढ़ते हैं, इक्वेशन ऑफ लाइन, जिसमें x जो है वो वेरिएबल रहता है। उसके साथ पहले हम क्लास 7th 8th में मेरे ख्याल से बनाते थे दो टेबल टाइप से, तो उसमें x की वैल्यू रखते थे जिससे y की वैल्यू चेंज होते जाती थी। x की वैल्यू फिक्स रहती थी 1 2 3 4, और उस x की वैल्यू रख रहे हैं तो पूरा इक्वेशन के हिसाब से y की वैल्यू चेंज हो जाती है। तो ये जो y है ये यहाँ वोल्टेज है, ठीक ना। x बना रहा है y को, y x को नहीं बनाता है। y इज इक्वल्स टू 4x, सिंपल, y इज इक्वल्स टू 4x। अब x की वैल्यू जैसे जैसे चेंज होगी वैसे वैसे y चेंज होगी। तो x को हम बोलते हैं इंडिपेंडेंट वेरिएबल मैथमेटिक्स में, और y को बोलते हैं डिपेंडेंट वेरिएबल। सेम यहां भी है, v इक्वल्स टू आई आर। क्लियर एवरीवन? So this case study as it is will be your homework. Go through each and every question point कि केस स्टडी है तो उसमें सारी चीजें क्लियर होनी चाहिए। Now moving to next question. In one class at least we can do 2 case studies. So here is our next question. This will also be your homework. Topic will be case study, electricity. Yes, Harshit.
Yes, sir. Good afternoon, sir.
Good afternoon. Tell.
The magnetic field is the region
Hmm.
around the magnet within which its force can be exerted by another magnet.
Very good. What is the direction of magnetic field?
Direction of magnetic field.
Hmm.
Uh, the same as it is same at every point on magnetic field.
Okay. If I'm taking a bar magnet, what will be the direction outside the magnet and inside the magnet?
Uh,
Yes, Viram.
Yes, direction is from now north to south, and inside the magnet as the circle is the line inside. So the line seems like a tangent. So it is from south to north inside the magnet.
Okay. Yes, Mehul.
Yes, sir. Same. Outside the magnet, it is curved from north to south, and inside it is south to north.
Okay. Okay. So I think these two questions will be enough for many topics, many concepts. Yes, Harshit, you want to say something?
yes, sir. I want to say the properties of magnet.
Yes, tell.
It attracts materials like iron, cobalt, nickel.
Hmm.
And second, when it is suspended freely, it rests towards north or south direction.
Hmm.
and it is always present with two poles, North Pole and South Pole.
Okay.
If it is broken, then also it will be have two poles, North and South.
So two poles of one that is broken, or both are having the two poles?
All are having two poles.
Okay. So suppose magnet A has been broken to two parts, magnet A and B. So what will be the poles of मैग्नेट ए जो बीच से टूटा है उसी पॉइंट पे वो दोनों अट्रैक्ट होंगे कि रिपेल होंगे? जिस पॉइंट पे तोड़े हैं हम उसी पॉइंट को अगर टच करके देखें तो अट्रैक्ट होगा कि रिपेल होगा?
It depends.
How it depends?
No, sir, it will rebel.
Why? उससे पहले तो जुड़ा था वो, वहीं से तोड़े हैं हम.
When it is broken, it gains two more poles, North and South.
Very good.
They become interdependent.
Very good.
Dependent. Yes, sir. I wanted to say two more properties. That magnet, two poles in two magnets, the like poles will repel each other, unlike poles will attract each other.
Okay.
Yes, sir. That's
very good. So time up for the attendance, time up for the class also. Now those who are trying to give the attendance, the form has been closed. So that's all for today.